In this lesson, we're going to talk about how transport layer port numbers are used to identify conversations and applications that are the destination and source of transmissions. All right, so let's talk about setting up a server. When we set up a server to provide services over the network, we load applications on that server. For example, a web server application, an FTP application, or a mail transport application. When we set up these services, a port is assigned to them, a transport layer port to the service itself. Now, there are some standard services. Port numbers that are below 1024 are often called well-known ports. And the reason they're called well-known is because they're the most commonly used. For example, a web server listens for communications addressed to port 80. The FTP server to port 21. The mail server to port 25. These and many other well-known ports are automatically identified by the clients. Whenever we open a web browser and we type in a URL, we don't have to tell it what port, because the client, in this case the web browser, already knows that web servers are listening on port 80 to be able to respond to web page requests. So when our web server is listening, what this means is it has a buffer set up that will accept requests that are addressed to its IP address and also the TCP port 80. If the FTP server is expected to respond, the communications will be addressed to port 21. This enables us to have many different services running at the same time on the web server, so it can be doing many different things. Now, on the host side, host ports for TCP and UDP are dynamically assigned from the range above 1024. And those ports are randomly assigned. So basically, your PC picks one out of the range and it uses it as a source port. So say your web browser is open and you're requesting a web page. The web browser will pick a port, a TCP port. When the traffic goes to the transport layer, the TCP port will be destination, port 80, and source from one of the randomly assigned ports. So when the communications leaves the host and heads for the web server will see the destination port as 80. So it will automatically put this request into the queue for the web server to process. When the web server formulates its response, it will respond back with the destination port 5305 and the source port of 80. So when it comes back to the host will know that this is the request that was sent out from the web browser, because the port 5305 was assigned to the web browser request. TCP and UDP ports at the transport layer are what enables our devices to have open many different applications at the same time and have all of those applications communicating simultaneously. Because, for example, if I also had an FTP client running, I could send FTP requests with a different port number. So that would be destination 21 and source port 5307. So then the communications would come back here and it'd go through the same process. Would see that the destination port was 21. It would go in the queue for the FTP server, and when the response came back, it would be addressed to the destination port 5307 so that the host would know that that was the request from the FTP client.